So this is an Alesis Nitro drum kit. They're a great little drum kit if you're just doing some quick demos at home or a studio for MIDI data to try and get it out to your recordings, or just having fun practicing at home quietly with your headphones on. Unfortunately, like many of the not so expensive drum kits, I don't even know, I think these are like about $1,000 or $1,500 or something new. I'm not even sure if they're that much, but unfortunately the triggers in these cymbal pads don't last very long. Haven't had any other problems with the other trigger pads like the snare, the toms, and the foot controller and the bass. No problems at all, but the cymbal pads die, at least from what I've been seeing and what I've been reading. The problem is that once they die, they're between $30 and $80 Canadian if you can find them, and it's kind of a rip. You can actually take these things apart, is what we're going to do today, because I have three and none of the three work anymore. So what we're going to do is we're going to replace the sensor inside of these cymbal pads so that we can restore function to them. Two issues with these. Usually it's called a piezo sensor that's inside them, and usually either the sensor itself goes bad or a solder joint somewhere in the chain of signal gets broken. So what we're going to do is we're going to be taking apart one of the pads and replacing the piezo. If it's the piezo that's the problem, I'll go through a process of replacing that, but also checking the joints on the 1/4-inch jack that is on the little controller board that's inside. I shouldn't even call it a controller board. It's just a very basic circuit board that's basically there to hold the 1/4-inch jack plug, the male plug, or female plug, sorry. And so what often will happen is the soldered trace towards that plug from where the piezo is connected will fracture. So before you replace the piezos, you can check those. It's cheaper. But if you end up having to replace the piezos, don't worry. There's lots of them available online. I found a pack of 20 on eBay for under $10, I think it was. And basically, they come in a little package like that. So rather than go and pay, $40 to $80, which is a ridiculous amount of money for these, you can get a pack of these, 20 of these, if you're having problems with the piezo, and keep replacing them as long as you want. So anyway, we'll get at it. So we're taking this apart, and we're going to see if this one actually has a problem with the plug, or is it the piezo sensor? And I'm going to say probably the plug. Starting to lose confidence that it's always going to be the piezo sensor. It helps when I have the right screwdriver too. Although I don't think that's the right one either. Where's my screwdriver? Where's my screwdriver? I don't know. Thanks. Oh, light's going insane here. There we go. Ah, that's better. So, let's see. What are the bets? What are the bets? I'm betting that it's the plug. Fractured little circuit board. These screws are all the same, by the way, so it doesn't really matter if you mix them up. And I'm running out of places to put things. Okay, there we go. There we go, there we go, there we go. And we'll find out. So the that looks fine. So the piezo looks fine. Okay, so this one is different though. This one looks like it's already been, I don't know, maybe they just ran out of one color of plastic clip or plastic ret. Well, although the guy I bought these from had said that he realized he thought the piezos were all done, but look at this. I don't know if that's from factory or not. There's a lot of flux on there, burnt flux. Interesting. Alright, so we're going to have to take a look at this under the microscope as soon as I can start it up. I should have had it on already. And what's my computer doing here? So this ought to tell us what's going on. Although I don't have that much clearance for focus on the microscope, so we're going to try this crazy thing here. Okay. Where are we? Well, it's the same story as the last one. Kind of hard to see, although, let me just see. Can't see if this one is actually doing the same thing or not. I'll have to aha, yes it is. You can just see that movement there a little bit. That means the connection is also fractured on this one. So it isn't the piezo sensor, it's the joint. You can see it broken right there. Look at that thing moving around. Okay, well, appears to be the exact same problem. So we're going to do the exact same thing to fix the problem, which is to grind off the trace between these two connections and clean it up, run a new fresh bead of solder, and then in the center of that solder we're going to run a little piece of wire, multi-strand wire, to strengthen it. And that's about all we can do, really. I mean, that's really all we can do, unless we get a new little printed circuit board, which we don't have access to, and why bother? So anyway, that's what we're going to do. So here's my grinding pen. If you don't have one of these, it's fine. You can still do the job with this little sharp, fine-tipped X-Acto knife, and just be very careful you don't cut through the trace any more than you need to. But this is perfectly fine for doing the job as well, as long as you make sure you don't lean on it too hard and go right through the trace. All you're trying to do is scratch off the conformal coating off the trace. So you'll see that happening under the microscope. Yeah, I should have probably cleaned the board just a little bit better. And the audio for this, because I was under the microscope, I'm putting in afterwards. You can probably tell. But yeah, this is the process of basically very lightly removing the solder mask on the trace that goes from where the piezo connects to the female input, quarter-inch input jack. And so I've done this on several video clips that I recorded. So if they don't match up, it's the same process for each one, but some connectors look worse condition than others. But trust me, if they are fractured, they'll all be fine by repeating the same process. Also, I apologize, I don't have a Barlow lens on my microscope yet. I'm probably going to purchase one soon. It gives me a rather narrow field of view this way, but hopefully when I get that in the future, make a big difference. You can see more of what's going on. So now I'm going to go ahead and clean up a little bit of this trace with some 99.9% isopropyl. Don't use anything more or less than that. If you do use less than the 99%, 99.9%, 100%, whatever, the problem is it can leave standing moisture on the PCB, and that can lead to unseen or even seen corrosion, or taking into consideration that water can be conductive, will short out sometimes connections or circuits. So I don't want to do any of that. So now we'll add just a little bit of flux to the PCB, the trace area, and the connection areas. Don't use too much, you don't need that much, but just enough to cover the area. When it's zoomed in like this, it's really hard to tell. It looks like a ton, but really it's super, super small. Even these traces are very, very small in the big picture here. So you just want enough in there to make sure that when you add the iron and heat it up, that it has enough flux to cover the joint. That way when you add the solder will flow perfectly onto the joint and onto the cleared area on the trace, as you'll see here. So there you go, it's sticking very well. And you'll notice that no matter how much you try, usually it'll leave a gap between where the connector is, where the joint is that's fractured, and the other joint that we're trying to bridge. I mean, you can create a bridge if you drag it across, but I never would trust that. That wouldn't fracture again. So this is why we start with a base like this, but we're going to be strengthening it with multi-strand wire from one side to the other, because the multi-strand wire will really help keep that strong, and with any of the impact that you would normally cause on this trigger pad, it shouldn't fracture again very easily. I mean, it may over time, but the hope is that this will last at least a good while before this happens again. Or maybe you'll get lucky if you're not hitting them too hard, and it will last the life of the actual device or the trigger. Okay, well, I actually did make a continuous solder joint from one connector to, or from one point to the next, but I'm not exactly comfortable with it because it still has a bit of flex and it'll just eventually break that joint again. So what I'm going to do is, to help it stay and to help it stay strong and not lose its signal between the points, I'm just going to run a little piece of wire along this whole path all the way in here. So that should add some strength and help it not break off completely. So here we go. Let's add the multi-strand wire. I don't need to pre-tin it. All I did was take basically the same gauge wire that's used in the piezo off and twisted it, although I really didn't twist it very well in this one, but as you can see under the microscope, get back under there, you. Come on, come on. Okay, so here we go. And you'll see, if I can keep it under the microscope, it's because it's moving. It's moving because I don't have the proper jig to hold things in place, which I should get. I have to pick one of those up at some point for logic boards anyways. So there, that's pretty much bridged. You can see the wire sticking out through the edge of the joint. And all that's really left to do is to clean this up a little bit. trim off the wire like that. What I'm doing there, just trim that little piece off on that side, and then trim it off over here. Might be hard to get it under the microscope here. Let's just, there we go. And now you can clean it up again with some more isopropyl alcohol. Okay, it was supposed to be a video about replacing the piezo, and unfortunately, well, actually, there was one of them that had a bad piezo in it, and it looked more like a hack job that the other guy had done, attempting to repair it. I figured that because the piezo were the easiest part to replace. It's basically just two soldered wires that go into the PCB, so that's not a big deal. But what I ended up doing was just filming. This video became more of a how to fix the quarter-inch female jack that are on these pads rather than the piezo. Although, like I said, I did replace one piezo. But as you can see now, they went from all not working to ride cymbal, crash cymbal, pad. So they all work perfectly. All sensitivities are restored. Everything's 100%. These did not at all work before. So it is perfect now. And I have a little clip I may add of the piezo that was bad. I'll see if I can add it at the end of the video here, just to show you. Okay, so the last one. And I'm kind of glad I left it to the last one, because I open it up and I see that this one has actually been very poorly repaired before, and it does need a piezo sensor replacement, and this is why. So obviously the previous owner had tried to do a repair. Looks like the pad is ripped right off of the sensor, so that was never going to happen. So we are going to replace the piezo sensor in this one. And while we have it apart, I'm noticing this PCB is also loose. So this is going to be a replacement of the piezo sensor, as well as a repair of the traces on the PCB for the female quarter-inch jack. So let me just remove these 3 screws. And as I said in the previous video, and as I said in the previous clip, these screws are all the same size, so don't worry about mixing them up. They're exactly the same. So, oh boy. Yeah. So let's have a look at this mess. Oh boy. Yeah. Yeah, that's in bad shape. So we'll have another look at this under the microscope, but you will see, once we get it under the microscope, you'll see where the, again, where the trace is broken, except this one looks a little different. The last ones we repaired, there was a fracture in this joint right here, so we would bridge here to here and run a bodge wire from here to here, jumper wire. This one looks like this is fractured on this. It looks like it's fractured on this connection here, on this, and so I'll have to run. I'm going to clean this up first because it's extremely dirty, but I will have to run a bead of solder all along this ground off trace, and I will strengthen it with a multi-strand wire. That's pre-tinned. It'll help it adhere and go down into the solder better. So let's clean this thing up a little bit. And it's a mess. I don't know. Maybe the guy didn't have the proper equipment. I have no idea what happened, but I can tell you one thing. It isn't pretty. You do the best you can with what you have, I guess. Just wanted the thing to work, I'm sure. But it just made a big mess. So I'll clean this thing up as much as I can, just to get the make sure it doesn't clog up my grinding pen. If you're using a grinding pen, it's good to, which I didn't do in the last couple because it wasn't that bad, but in this one I want to really clean up as much of the old flux that he used as possible, because it will clog up the little grinding tip on the grinder pen if you're using one. And I'm just trying to make it as neat as possible so that we can see what we're doing a little better. Alright, so I'll be back. Okay, so it's hard to see from this distance, I'm sure, but I am running a bead of solder from, I don't need to go the full distance of this trace. This trace is pretty good from about here, and I just need to really add strength. So, and I also needed to add strength on the right side here of the trace and the left side because it was broken all around it. So, and you got to be careful that you don't cross over the two traces with solder, so you got to be careful there. The next step for me is going to be to desolder this old piece of junk here, piezo, but I have the brand new one here, and before I do that, as you can see, the new ones come with a clip on them. Gee, imagine that. That's because these are actually not Alesis. They're originally a Roland piezo, which they're exactly the same size, same spec, everything, but I guess the Roland system has a little bit of a better mechanism for plugging them in, whereas instead of just soldering the wire, but maybe not. Maybe these plugs after a while are crappy too, so and maybe it's better with a hard solder joint. But anyway, what we got to do next is we got to measure the distance of wire needed and cut that at the right length, and then re-feed them through these holes here, solder them, and then we can proceed to correct all of the issues that still remain by running a little wire, multi-strand wire between here and here, and maybe even back here, and then here and here to make sure that that connection stays strong. This repair was covered earlier in the video. You saw close-ups of me repairing that. So that'll be it for this video, but thank you guys for watching. See you in the next video.